Okay, we're going to look here at the second question I gave you. The first question was on the big seven ideas from first semester, and then this idea is I think the bigger ideas from second semester, and that is um, uh, fundamental theorem of calculus, which obviously is the biggest deal, and then absolute max and min with the fundamental theorem of calculus. Um, Obviously, there are other big ideas, but I just thought, in terms of, and I know this practice test is a little bit on the easy side, but I thought just kind of wanted to do some broad strokes here. Okay, fundamental theorem part. What is g of negative 5 and what's g of 5? So again, all that means is you put the negative 5 in here, and obviously if you integrate from negative 5 to negative 5, that is a big 0. Okay, and that's just just to remind you that if you get fundamental theorem, g of 5 minus g of 5 is certainly going to be 0. Now negative 5. Now if you're going to integrate all the way to 5, you're going to need to find these 4 areas. Now you might think there's only 3 areas, but I think if you think of this area here, this area is I would probably break it into a rectangle and a triangle. 2 times 3. So that's 3, 3, so this is 6. So that area is 6. This is a triangle here. 2 times 3, 1/2, 2 times 3, this is 3. So this area is 6. Now, remember, I'm putting it in red because it's going to be negative. If we're going to integrate this way, from negative 5 this way, and then this is going to be 3. Now, hold off on this one. This was 3 cosine pi over 2x. And then this last one is half of a circle. 1/2, radius is 2 times pi. This is 2 pi. So the area is going to, so it's going to be negative 6 plus 3 plus this one here. Now we haven't done that one yet. Minus 2 pi. The red ones are negative and these 2 green ones. And I haven't done this region yet. I think the way the AP exam is going to do this is very similar. They're going to give you 3 geometric shapes: a trapezoid, a triangle, and a half circle in this case. I don't know if they're actually going to be on the test. They'll give one that you have to actually do by hand. So just a reminder on this. I'm going to have to do the integral of 0 to 1 of 3 cosine pi over 2x dx by hand. So take the 3 out. And then it's up to you. You have to do a U substitution here, or a reverse chain rule if you want to think of it that way. You can do that in your head, or you can do that by U substitution, showing it. I would show it here. X. Or I'm going to show it here. I probably would do it in my head if it were me. Pi over 2 dx. And then what is that? If I put 0 in, 0 times anything is, of course, 0. And then what if I put pi over 2 in? No, sorry, I put 1 in. 1 times pi, which is pi over 2. So remember how this works. The 3 sits there. But then you have to remember, you got to divide by this. So that's going to be 2 over pi, 0 to pi over 2 of cosine u du. So 3 times 2 is 6. So you end up, remember, you're doing a reverse chain rule here. So instead of multiplying by pi over 2, you have to divide by pi over 2, which is multiplying by its reciprocal, which is 2 over pi. So what's that? 6 over pi. Antiderivative of cosine is sine. The sine of pi is over 2 is 1. The sine of 0 is 0. So I get 6 over pi, 1 minus 0, which is just 1, which is just 6 over pi. So 6 over pi. Now, feel free to leave your answer like that. I'm going to put it together here and write negative 3 plus 6 over pi minus 2 pi. Now that's the first part, and that's on the fundamental theorem. And I know this question is a little bit easier than you might anticipate for the exam, but just again, broad stroke. I think they're going to do a fundamental theorem where you're actually going to have a lot of geometric shapes that you can probably do without doing the integral, but they probably will have you do at least one integral at some point on the question. Okay, now I want to do absolute max and min. So what I'm going to do here is I'm just going to erase how I did the calculation of that 6 over pi. So just a note here, this region here, I'm going to put it in black, although it should be in green, is 6 over pi. I think I'm going to need that in a little bit for the next question. Okay, so now we want to look at absolute max and min, which is the thing I think that they'll end with here on this question. And it's often like the last question in this question, right? So let's finish it. Let's find absolute max and min. And obviously, just like the last question where I had you find concave up, concave down, increasing, decreasing, max, relative min, and flex point, they probably won't ask you for all 7, just a couple of them. And same thing here, they'll probably only ask for max and min, but I'm gonna just do both here in this situation. Okay, so what do we got here? You have to check the endpoints, -5 to 5, because the integral went from -5 to 5. And then you have to check the critical numbers. Now the critical numbers are obviously when the derivative is 0. At -2 and at 1. Now, if the AP exam is nice like I was, the g of 5 and the g of -5 we already did. -3 plus 6 over pi minus 2 pi. And then now the -2, so that's this one here. And that's just this one here. So you just integrate from, you put -2 in, so you get from -5 to -2. That's just that one region, which is -6. Then if I integrate all the way over to 1, I'm going to have the -6, the +3, and the +6 over pi, which I guess you could simplify this to -3 plus 6 over pi. Now you're going to have a calculator, and I kind of did this on purpose, just to make, remind you that you're going to have a calculator handy. So what you want to do is you're going to put -3 plus 6 divided by pi minus 2 times pi, and you get -7.373. And you don't really have to worry about decimals too much, because I'm doing this more just to find which number is the biggest and which one is the smallest. -3 plus 6 divided by pi, -1.90. Okay, so obviously this is the most negative. They're all negative except the 0, so that's got to be the most positive. So the absolute max is 0. The absolute min is, this is a G. Sorry. This is a G. Turns out to be at the endpoints. Oh, boo. I like it if just from a teaching perspective, I like it if one of the two is an inflection is a critical number. In this case, that's not going to be. Don't write that number though. Be on the safe side. Write that number. I suspect you'd get credit for it, but I wouldn't. I'd do that. Oh, can you see that? Just in case you couldn't see it. But not like this, just in case. There's the bottom of the board.